Alright, so today we are going to start a new topic, that is the open channel flow. So open channel flows are different from pipe flows. Till now we have not seen anything other than pipe flow. So today we are going to start the open channel flow. In today's lecture, what we are going to discuss? We are going to discuss about four things, four major aspects we will try to discuss. First is we'll try to understand what is an open channel flow. We'll see some examples, we'll discuss some examples of that. Then we'll see what is the difference between pipe flow and open channel flow. And we will also discuss why should we study the open channel flow, what are the uses of studying the OCF. Alright, so let's start with the definition, or what exactly is the open channel flow. So basically, open channel flow is the flow which takes place due to gravity force. It takes place due to gravity force and forms a free surface which is having atmospheric pressure. So let's say there is a channel like this. Suppose you walk down your locality, you might see on the side of the road you might see some drainage, some structure which is constructed so that rainwater drains off through that structure. Suppose that it looks something like this, suppose, okay. In the cross section it looks like this, okay. And suppose you put water in that drain, suppose rainwater comes, alright, and it will flow in this way, okay. This is along the length, alright, along the length. Okay, flow direction. This is the flow direction. Now what happens if you put water in this drain? If you consider a control volume, let's say this is a control volume. Let's say this is a control volume. Just observe what will happen in this control volume. Suppose you put this much water in this channel. So what will happen? The water will have some weight. Okay. Now this channel will have some slope. Okay. Some angle theta, it is having some slope, okay. So weight will act vertically downward, okay. This is W, but some component of this weight will act in the direction of along the length, along the flow direction. So you will have some W cos theta also, sorry, W sin theta also, because this is the theta. So, and you will have this W cos theta. Okay, so you will have two components. W cos theta is acting normal to this channel, and component W sin theta component which is acting in this direction, along the flow direction. So because of this W sin theta, flow takes place, and the water will flow along the channel. Okay. So if you take a cross section, you will see something like this. So this is the depth of water and this is the flow area. Okay. So this type of flows are called as the open channel flow, in which the flow takes place because of the gravity force. Now what about the pressure? You try to understand the surface, the free surface which is exposed. This surface is exposed to the atmosphere. So pressure acting on this free surface is atmospheric pressure. So this pressure is a atmospheric pressure. So pressure acting on the surface of the on the free surface, pressure acting is the atmospheric pressure. Alright, that's why it is also called as free surface flows. These flows are also called as the free surface flows. So basically, this is what is an open channel flow, in which flow takes place due to gravity force and you will have a free surface having atmospheric pressure. Alright. Now what are the examples of this open channel flow? There are many examples of this that you can see. You might have seen already examples. Okay. We already see open channel flows in day-to-day life. For example, we see open channel flows in sewers. Along the roadside there are sewers to drain the water, to drain the rainwater, storm water, okay. Those are called as sewers or storm water drainage, okay. Those are an examples of open channel flow. Okay, again you have seen flow in the reverse. You might have seen a river. Flow in a river is an example of open channel flow. Again, you must have seen some hydraulic structures such as, let's say, spillway. Okay, spillway. The flow over spillway is also an example of an open channel flow. Okay, so these are some few examples of open channel flow. Now, what are the basic differences? What differentiates the pipe flow? And so this is all about what is open channel flow. Now, what is the difference between pipe flow and open channel flow? This we'll try to understand. So let's say you have a pipe flow. So you have a pipe here. This is the center line of the pipe. Okay, let's consider some datum, arbitrary datum. Okay. Now, along the center line of the pipe, if you try to draw the hydraulic gradient line, how you will draw that? So let's consider one point. Okay, the height of that point from the datum is the potential head, isn't it? This is the datum head or potential head. Then you measure how much is the pressure head. Just put a piezometer tube, and the level of water or the level of fluid rise in that tube will give you the pressure head. Okay, so let's say you put a tube here, so you will get some some liquid or fluid will rise up to this level. So this is your pressure head. All right, so in this way you can calculate the pressure head. Okay, then you can calculate the velocity head also by measuring the velocity. So let's say P1 by rho g, you get some pressure head like this. Okay, this. And on some other point you do the same thing. You calculate what is the datum head, measure what is datum head, measure what is the pressure head. Okay, suppose it is like this. So you will get some line. If you connect the line which shows you the sum of datum head and pressure head, this line will represent what? This is your hydraulic gradient line. This is your hydraulic gradient line. Now see, in pipes the flow takes place because of the pressure force. See, on this cross section some pressure is acting. Okay, on this cross section some pressure is acting. Difference in the pressure forces will drive the flow through this pipe. Alright, and hydraulic gradient line will lie above the pipe surface. Okay, and the hydraulic gradient will always lie above the surface of the fluid in case of a pipe flow. Now if you look at an open channel flow, now I am not drawing the velocity head because it's not needed right now. So if you let's observe an open channel flow. So how you can get an open channel flow? Just give some slope to a channel. Okay, so water will flow because of gravity force, so you will get an open channel flow. Okay, now see, if you look at a certain point, if you want to study the hydraulic gradient line, if you want to draw where the hydraulic gradient will lie, you can just take a sample point. Okay, and you know now this is the height of the water, so at any point what will be the hydrostatic pressure? It will be triangular, something like this, isn't it? It will act something like this. So pressure head at any point, how much will be the pressure head? It will be exactly above, it will be exactly the depth of flow above that point. Okay, so this surface itself represents the hydraulic gradient line. Okay, so when you have an open channel flow, the free surface, the water surface or free surface, I'll call it, free surface and hydraulic gradient line are coinciding. The free surface itself is the hydraulic gradient line, not unlike the pipe flows. Okay, so this is one major difference, that firstly Here the driving force is the pressure, and in case of open channel the driving force is gravity force. So these are some differences between pipe flow and open channel flow. Alright, now we have seen this. Now third question is, next question, why should we study open channel flow? Okay, there are several reasons to study the open channel flow. I will just discuss very few simple reasons. Alright, we will not go into the complexities. As we go ahead, we will discuss some complex situations where we need to study the open channel flow. So very basic needs we will try to see. So let's say you have a river, okay, a river whose L section is like this. In surveying you must have seen what is an L section, okay. So this is your L section of the river along the length of river, okay, length of river, and this is the water depth, okay. So it is an open channel flow. Flow is taking place in a river. This is the flow direction, okay. Now you know that river, if you look at the cross section of that river, take a cross section here, suppose, okay, take a cross section. So you might see, so if you take go on the field, you take your instruments, leveling instruments, let's say auto level, you take auto level, and you do the surveying, bathymetric survey you do, and you plot this cross section. Suppose you get this cross section, okay. So this is your river, okay. Now when you will do the bathymetry of an actual river, you will see that there are two parts of a river, two distinct components in the geometry of the cross section you will observe. First is the gorge portion, or the channel section or channel portion, okay. This portion which has a greater depth of water is a gorge portion, okay. Then, so this is suppose water level, and then you will have from the gorge portion to the on the both sides, left and right, you will have left and right banks, okay. Those are called as bank portion, bank or floodplain, okay. So in this way you will get something like this, you will get some cross section like this after doing the survey. Now what happens is, generally our rivers are inhabited on the bank portion, okay. You will see a lot of human inhabitation on the banks. You will see buildings, you will see some residential area, some people living on the banks, there are some fishermen who live on the bank, they have their homes, they have their work setups on the bank, etc. Now what happens is, now generally throughout the year the water is in the gorge portion, okay, water is here like this, okay. But sometimes what happens in the rainy seasons, we have seen that sometimes we get a lot of rains, and we get intensity of rainfall is high in a small duration. So what happens? So what will happen? The rainfall which has fallen over the catchment, what will happen to that rainfall? A significant part of that rainfall will be converted into runoff. A significant part of that water will be conveyed by this river, okay. It will come into the river. So discharge of the river will increase, flow rate of the river will increase, and because of that increase, because of that flood, sudden flood, you will get a flood. Sudden increase in the rainfall, you will get some floods, and therefore this water level will increase. Suppose it goes like this, okay, goes like this, water level will increase in the river. So there are chances of flooding, on the bank portion. So there is a risk to human life. Okay, so there is a great risk to human life when we have flooding. So why we should learn the open channel flow? Because sometimes we have to predict. So if so and so, if we get some flood, what will be the water level in river. So this question has to be answered, because once we know what will happen, how much depth of flow will be there in the river, then we can arrange some safety measures. We can take those people outside the risk zone. Okay. So this question can be answered if you study the open channel flow. So study of open channel flow will help you to answer these questions. Okay. Next, one example I will give you which everybody can connect to, that is the bridge scour. Okay, so let's say you have a bridge like this. So you have a river, okay, some river, this is the plan of the river, okay, river is going like this, okay, and some bridge is constructed here, some bridge is constructed here, these are the abutments, okay, and you have some bridge piers on the river, okay. Now generally you have this river bed, okay, and you have this bridge pier, okay. It is not this simple, but right now I am just doing it for simplicity, okay. So this is your bridge pier, maybe it is a circular pier, okay, maybe it is a circular pier. From the plan it will look like this, circular pier. Now water is flowing like this, okay. So this is the water level, suppose. This is the river bed. Okay, this is your pier, bridge pier. Okay, now see, when you have a bridge pier, this is a hydraulic structure because it is inside the river bed. Now what happens is, when flow takes place around a bridge pier, the river bed is not rigid, the river bed is mobile. Okay, why it is mobile? Because it is composed of sediments, and sediments can move because of the forces acting by the exerted by the water. Okay, so flowing water will exert force and the sediments are free to move. Okay, so the motion of the sediments depend upon the forces acted by the flow. Now, so what happens basically when you have a bridge pier generally is that because of the flow structure which is developed around the bridge pier, you will get a erosion around the pier and the bed level will go something like this. Okay, so this will be the river bed level. After the construction of a bridge pier. Now see what happens, this particular area of erosion is called as the local scour. Local scour. The erosion which is developed around a bridge pier locally, that is called as the local scour. Now what happens is, because of the local scour, it may happen that the scour will go beyond this depth, below the level of the bridge foundation, and because of that the bridge foundation can be there is a risk of failure of that bridge foundation. It can get undermined. That's why to decide the foundation level, we have to find out the maximum scour depth. We have to calculate how much will be the scour depth over a period of time, so that your foundation level, this foundation level should be always greater than the maximum scour depth. Otherwise, there are chances of failure of that structure. So, this calculation for this study, for calculating the maximum scour depth also, we have to look into the open channel flow. So, this is another example. So, there are several examples like this where you have to study the open channel flow and get the engineering solutions. One more simple example is, now generally we need water for irrigation, agriculture, isn't it? So irrigation water is needed throughout the year, and from the rainfall we get water only in the monsoons. So what we do is, we have constructed a lot of dams. So you have suppose a catchment. So this was a river earlier and you constructed some dam suppose. Okay. So water has now stored in the reservoir. So you formed a reservoir. This is the plan view. This is your dam. Okay. So now you have a reservoir of water and you want to supply this water for irrigation to this is the upstream and this is the downstream. Okay. So you have to supply this reservoir water to the downstream agricultural fields suppose. Okay. So how to do that? We do that using the open channel flows, canals, a network of open channel canals. Why? Because it does not, flow in the open channel does not require any pump, because flow takes place because of the gravity. So we use that and we supply water from this reservoir to downstream areas using open channel networks, network of canals, that is called as. So we have to study open channel flow so that if you have designed a canal, then water should be able to flow through that canal at the required depth and without causing any siltation and scour. Siltation and scour means the sediments which are there, small sediments suppose you have in the water, they should not get deposited here, they should get moving. They should always keep moving in the flow and you should also get the required water depth so that farmers are able to collect water from this canal. Okay. So this is another need or use of open channel flow for designing of canals. Alright. These are some basic examples or basic what you can say areas where you apply the open channel flow knowledge. Another area is the river hydromorphology or river morphodynamics. This is also one of the complex areas which starts from which needs the knowledge of open channel flow. Basically, river morphodynamics means basically when you have a river, so cross section of the river if you see, then river cross section is a mobile boundary. Mobile boundary. Okay, because it is made up of sediments. This is not rigid. Okay, so when water flows in this cross section, there are chances of what will happen where some velocities are high, water will exert greater shear stress on the this mobile bed. Some area might get eroded. Okay, so maybe after some point of time, the river will look like this. Okay. The cross section might change, okay, after certain point of time. Why? Because velocity distribution is different and because of that the shear stress distribution is also different in a river. So because based on that shear forces, the erosion and deposition will also change of the bed sediments and you will get a different cross section after certain time. So when you have to study the changes in the river morphology, and this study is called as river morphodynamics, and for that we have to study the open channel flow. So these are the various examples or areas where we need the knowledge of open channel flows. And from the next time we will start with the basics of open channel flow and its governing equations. Thank you.